This is the second part of 5.5 factor theorem. The factor theorem states that a polynomial f of x has a factor x minus k if and only if f of k equals 0. If I'm going to factor this polynomial, given that x minus 3 is a factor, the first thing we're going to do is synthetic division. If x minus 3 is a factor, what the factor theorem states is that positive 3 must be a 0. So what we're going to do is we're going to put 3 in the little box because 3 would be a 0. Now I'm going to write these coefficients with the constant in order. So we'll go 2, negative 11, 3, 36. Okay, leave your space. Remember this first number 2 drops down. Then we multiply here, so that'll be 6. Whoa. And then we've got negative 5, multiply to get negative 15. And then we've got negative 12. And then we have negative 36. And that adds up to 0. Now, because x minus 3 is a factor, this last number should always be 0. That means that there is no remainder. Now, this number here, this term is x cubed, so that means down here we're going to start with x squared. This is going to be our x term, and this is going to be our constant. Okay, so what they're saying is that x minus 3 was a factor, then also 2x squared minus 5x minus 12 is also a factor. And then the last thing you would do is double check to see if you can factor this trinomial any further. So we would drop down the x minus 3, and then we're going to see if we can double bubble this, which means factor. So we've got 2x and x, factors of 12. Let's try 3 and 4. Remember then inside we get 3, outside we get 8. So I would have to make it negative 8, positive 3 to get this negative 5. Check the signs, positive times a negative is a negative 12. So this would be my final factored form for that polynomial. Another one. They're telling us that x plus 1 is a factor. That means that negative 1 has to be a 0. So now I'm going to write these coefficients again in order. 1, negative 6, 5, 12.
I'm just probably gonna.
Now that we've put those coefficients in order, we're going to bring down this 1. So I have 1, multiply to get negative 1. There's negative 7, 7, 12. That'd be negative 12. And this turns out to be 0. Remember, this last should always be 0. There should be no remainder. Okay, so since x plus 1 was a factor, then down here again we have to start 1 degree less than what we had up here. So it would be 1x squared minus 7x plus 12. Okay, and then we see if we can factor even a bit further. X plus 1 is a factor, and then if I double bubble this, we've got x and x. Factors of 12, that'll give us 7, will be 3 and 4, and they'll both have to be negative. Double check the signs, negative times a negative gives us a positive 12 at the end. So that is our final factored form for that polynomial. Now they're going to ask us a little bit different question. We're still going to follow the same method. Notice this time it says 1 0 of this polynomial is 4. What are the other zeros? Now they're telling us that this number is the 0. That means that 4 has to go in the box. Okay? Notice the difference. This problem back here, x plus 1 was a factor. So we take the opposite sign, that would be the 0. So that's why we put the opposite in this little box. But now when they tell us that the 0 is 4, that's what goes in there. And now we're going to write the coefficients in order. 1, 1, negative 16, negative 16. Okay, and then we continue, bring down the 1. So we have 4, that's a 5, and that'd be 20. That gives us positive 4. 4 times 4 is 16. And again, we should have come up with 0 at the end because 4 is a 0. There should be no remainder. Okay, now I do not need to write this out as a whole bunch of factors. What I will need is to write the division out for this problem. That would be x squared plus 5x plus 4. Now, again, I am going to try to factor this. So I've got x and x, factors of 4 that'll give us 5 are 4 and 1. So these are both going to be plus. Okay, those both add up to 5, multiply out to positive 4. Okay, now that's the factored form. If I were to figure out what the other zeros are, you think about what would make this equal 0. So my other 0 would be negative 4. And then for this one, if I set that equal to 0, I'd have to subtract 1, which would give me negative 1 for a 0. In other words, opposite signs of what's in the parentheses. Okay, so those are the other zeros besides 4 for that polynomial. One more example of those. This time they told us that negative 2 is the 0. So I'm going to put negative 2 in the box. And then I write my coefficients in order. Always make sure sometimes you may have to put a 0 in place up there. I haven't had to for any of these problems, but sometimes you do need to. Okay, so I'm going through and doing the math here. That gives me negative 7, positive 14. Again, we always want 0 at the end. Now I'm going to write out what I would have if I divided. My answer would be x squared plus 6x minus 7. Now we're going to factor that. So I've got x and x, factors of 7, that'll give us 6, are going to be 7 and 1. If I need a positive 6, it's got to be plus 7 minus 1. Positive times a negative gives me this negative at the end. So now what are the other zeros? For this one, it'd be negative 7. And for this factor, my 0 would be 1. So negative 7 and 1 would be my other zeros for that polynomial. And that's going to conclude the rest of section 5.5.